This is Dr. Jack Jackson, and this is part 6 of our series of lectures on descriptive statistics. And this part will be identifying outliers. Outliers are exceptionally unusual data values that are either extremely higher or extremely lower than the other data values. When you have outliers, you should be careful to try to determine what the cause is of the outliers. Is it possibly that you've collected the data wrong or recorded the data wrong? Maybe it's a data entry error. Or there's something about that data that's very unusual. And perhaps it should not be part of the data set. For example, if you're collecting salaries for a company, it may be that you should throw out a couple of people at the top, maybe the CEO and the top vice presidents, because they're not really typical of the rest of the data. So you may have more than one data set mixed in together for some reason. So how do we identify outliers? Well, we can identify outliers a couple of different ways. One way is by looking at the standard deviation. So we recall from Chebyshev's theorem that in any distribution, no more than 11% of the data is beyond 3 standard deviations of the mean for any distribution. And we also know if the distribution of the data is symmetric, mound-shaped, in other words, if it's close to a normal curve, then for a normal curve, no more than 0.3, 0.3% is beyond 3 standard deviations of the mean. So if the data is mound-shaped and symmetric, somewhat like a normal curve, you would expect something around that level. So anything that's beyond those 3 standard deviations is going to be considered an outlier. So remember that the z-score is a measure of how many standard deviations a certain measurement is from the mean. If that absolute value of that z-score is greater than 3, then we're going to consider that data point an outlier. We can also figure out our outliers via the quartiles. So if you have a box and whiskers plot, for example, you can figure out an outlier based on that. So here's the idea. If you're way small, how small? Well, 1.5 times the interquartile range below the first quartile or lower quartile. If you're down that far, then you're considered an outlier. And if you're equally high, that's also considered an outlier. In other words, if you take the third quartile and you're beyond 1.5 interquartile range above that, excuse me, that will be considered an outlier. So remember, the interquartile range is that distance from the Q1 to Q3. Figure out how far that's the size of that box, that middle half of the data in the box and whiskers plot. Figure out how long that is, multiply that by 1.5, and go out there beyond above the third quartile and below the first quartile. If anything's outside of that, that's considered an outlier. Sometimes when you have a box plot, you will do a modified box plot. And so by using the criteria that we just talked about, if a data value is considered an outlier, then instead of drawing the end of the whisker all the way to the minimum and the maximum, you draw the end of the whiskers to the extreme values, the most extreme values that are not outliers. And then for the outliers, you put a special symbol like a little star, an asterisk or something, at those outlier locations. For my class, we will not be asked to generate a modified box plot as far as you making one. But if you see one, you'll need to be able to interpret what it means. So for example, here's a box plot of the sales data from our project that we worked on. And we had a couple of outliers. So our whisker only went down here to below, what is that, probably about 8 or 9 there. And then, but there was an outlier way down here. Somebody who sold exceptionally small amount of boxes of candy, I believe it was. I believe this was Ashley that sold not very many. And there was also an overachiever up here that was an outlier that sold way more than everybody else. So notice that if you take the length of this box part here, and we go that far out, and then half of it again, we're in here somewhere, and that data is below that, above that. And then down here we go 1.5 times this would put us in here somewhere, and this data value, this outlier, is way below that. So you can see the outliers there. If we did this with just a regular box plot, the whisker would go all the way up to that maximum and all the way down to that